All right, it is my pleasure, my great pleasure, really, to revive this series of interviews with neuroscientists centered around the journal Psychopharmacology, which we've been calling Psychopharm Friday. And since it's been over a year since my last interview, which is not coincidentally coincides with the birth of my daughter, I figured that given the time off that I've taken, I better bring a particularly special interview to kind of break the seal here. And I suspect that this conversation will be worth the wait. And so it is my great pleasure and honor to introduce Dr. Nii Addy, who is the Albert E. Kent Associate Professor of Psychiatry and Cellular Molecular Physiology at Yale School of Medicine. He's an accomplished neuroscientist with a special interest in nicotine and nicotinic receptors in the brain. And he's also the inaugural director of scientist diversity and inclusion at Yale School of Medicine. He's a renowned mentor and a leader in science communication, especially via his popular podcast, Addy Hour. Welcome, Dr. Addy.
Thanks so much for having me. It's an honor to be here, especially with what you've been doing and the guests that you've had come through already. It's been fun to kind of check out and listen to some of those interviews as well. So I'm honored.
Fantastic. Yeah, I've been extremely lucky to have some great scientists, and as I said, it's amazing to bring you in to kind of break open this another second season, if you may want to call it. Okay, so I think we'll start today by discussing your 2013 paper in psychopharmacology, which is called Ventral Tegmental Area Alpha 6 Beta 2 Nicotinic Acetylcholine Receptors Modulate Phasic Dopamine Release in the Nucleus Accumbens Core. This is Wickham et al. In 2013 in Psychopharmacology. So, Dr. Addy, could you tell us something about what the main findings of this paper were?
Yes, definitely we can jump into that. Before I do, I will say it was a nice experience for me to actually go back to that paper too, since it's 10 years old. There's some pieces about that which we'll actually talk through. And this is going to sound funny, but it's kind of interesting to reread what we wrote back then, see what things we focused on, what things have changed, how we communicate aspects of the science. But the basic premise was we were really trying to understand nicotinic receptor regulation of dopamine signaling and looking at that within a specific pathway, the ventral tegmental area to nucleus accumbens pathway. So thinking about the reward system in the brain. There had been a lot of work at that point looking at those nicotinic receptors within the nucleus accumbens, within the striatum, and how that regulates release within the striatum. But we also wanted to have an idea of how that was actually regulated upstream in the VTA specifically, since those VTA neurons project to the nucleus accumbens and other areas. So that was our main question of interest. It's funny because going into the project, I'd also been influenced by reviews that had come out in the literature. There was one review from Uwe Maskos, I think it was back in 2008, called Acetylcholine, the Neglected Master Modulator of Dopamine Signaling. So that very much also influenced and impacted our motivation to do the work. But basically, we're looking at different receptor subtypes in the VTA using specific pharmacological agents to inhibit specific receptors. And we were able to do that through collaboration. So we're able to collaborate with Michael McIntosh, who'd done a lot of work actually isolating conotoxins that could target specific subtypes. And basically what we found is that alpha 6 containing nicotinic receptors seem to be the key receptors that actually regulated that burst firing evoked release in the nucleus accumbens. People had done physiology to actually look at the firing of the neurons. We were looking specifically at how those neurons actually impact release in nucleus accumbens if we stimulate burst firing directly into the VTA with stimulation. So we basically combined that stimulation with pharmacology in the same animal at the same time and looked at different receptor subtypes of classes and found those alpha 6s were particularly important for regulating that phasic release.
And so those alpha 6s, these are on dopamine neurons themselves in the
Yes.
VT, correct?
Mm-hmm.
Okay. Very interesting. So that's yeah, you're definitely this is one of those stories in science where you kind of see this hole in the literature, and there's an influential review paper like the one you mentioned can often
Mm-hmm.
shape other people's careers too. So this is
Yeah.
one of the fun things about science. It's a sort of interactive nature and building upon prior work and plugging these holes to gain new knowledge. So is there anything else that's special about this paper, or any kind of stories around how you decided to do this project other than what you've already mentioned?
Yeah, a few stories. So this was actually the very first paper that we published from my lab when I started the lab in 2010. So we'd submitted it in 2012. It got accepted in 2013. My first graduate student was the first author on that paper, so that was another key piece as well. And then just thinking about how do we actually craft a story. So there had been a lot of work already looking at MDA receptors specifically that regulate burst firing of these dopamine neurons in the VTA. It also been tied to how they eventually release dopamine in these phasic types of responses, these rapid responses in the accumbens. So there's also that piece where we used a lot of that, even in terms of, okay, this is our first paper. What are we trying to look at? we need to have an NMDA receptor control. So we had NMDA receptor activation, inhibition, saw that still regulated dopamine signaling. We actually combined that with our alpha 6 manipulations, didn't see any additive effects. So that suggested these were actually working both within the dopamine cell body through the same downstream mechanism. So there were a lot of different components of, okay, this is the first lab. We don't have a reputation as an independent lab. There's this data before that's suggesting X, Y, and Z. We have to be able to replicate that. We have to also make sure we're pushing things forward to look for new findings. So all those pieces were all kind of tied in together. And obviously, even though we talk about our science and how we go through things systematically in the lab, there's a lot of emotion involved with that as well. When you're doing the first experiments, when it's your first student, is this going to work? Is this not going to work? There's also an aspect of I had to train my first student, Rob Wickham, to actually learn the voltammetry technique. So there was some patience involved in that while still trying to push things forward so that we could get our first paper from the lab. So, I mean, there's lots of different through lines I could kind of pursue, but that just kind of gives an overall picture of the many different things that we were thinking about as we were putting together an important paper, but in some senses, what you could also look at as a simplistic paper in a sense, but also a lot of work that went into that paper just to set it up. And not simplistic in a diminutive way, but in terms of really trying to have a narrow question that we were looking at so we could move things forward.
Yeah, this is a really hard thing, especially when you're first starting a lab and you're kind of trying to put yourself into the world, create an identity for yourself in the scientific community. You know, bite-sized chunks are always tricky
Mm-hmm.
for people, people that are really smart and know a lot about the field and want to make their own impact on it. Like, how do you turn this into an actual story of one paper, and not just get kind of carried away? I think that was something that I struggled with when I
Mm-hmm.
started my lab was trying to, you know, understand how to actually finish a project and kind of like
Yeah.
draw the line somewhere and say this is what we've done here and then move on to the next things without getting kind of too excited about all the other things you might do with your own
Yeah.
lab and all the people in it and stuff like that.
Yeah. No,
Yeah.
that's a great
And
point. We definitely had those tensions too. And I think when people look at the paper, you can kind of see that even in the way we wrote the introduction and the discussion. Because there were so many pieces that we pulled in that you could tell we were thinking about, but it's almost like we had to stop ourselves from trying to pursue every question so we could just at least start to build a story. And then we also had to realize that's why we have the lab to continue to do. It's not we don't have to put everything into that first paper, even though that's a tension I think for people sometimes to try and do.
right, especially when you're doing it kind of by yourself for the first time, it's definitely a learning curve there. So on that point, like if you were to do this kind of project today, is there anything that you would see yourself doing really differently in terms of, how you handled the people helping you write it, in terms of the actual experiments or interpretations?
Yeah, I think there probably are. I mean, initially, one thing I'll just say is I felt very blessed and very fortunate to have a really invested graduate student who was a strong writer. So he'd already actually written a review paper with us because I could see some of that investment. So from that standpoint, it was really helpful to have someone who was already strong in writing to kind of really just guide along the process. I mean, some of the things I'd probably do differently are mostly because of I have retrospective perspective now. So maybe even in terms of, I guess I would say I would probably differentially manage the manuscript development in terms of I was really trying to figure out how much of this do I let the student run with it versus how much do I put into it myself. And with my personality, I'm much more likely to kind of step back and let someone run with it and make decisions, which I think is healthy for mentorship and development. But in retrospect, there's probably some things where I would have had more input into cautionary things that I saw coming up down or earlier on to just say, okay, and the way that even a committee works, where a thesis committee is there really there to help guide you. Most people think when they're going to committee meetings, oh, this is a committee that's going to be punitive and they're going to tell me what I'm doing wrong, where they're really there to help guide you. And so sometimes if they see you taking a turn that's not going to be helpful at all, you're going to spend a year and not get anything out of that. They'll redirect you. So I think in retrospect, having more mentorship, I might have done more redirecting at earlier points, even though things still worked out. But I'm noticing that as the years have gone on, that sometimes I can use more of my experience to help shape, not to say this is a bad idea, but to say, well, let's think about that a little bit more. Is that really worth spending the time to develop that type of technique? So not anything specific about the experimental design, but just having a little more wisdom in how we went about it and how it mentored.
Yeah, all this stuff really resonates with me as well. This is, I think, probably a really common struggle there because, obviously you're starting your lab. I mean, especially at Yale. I mean, the
Yeah.
expectations are going to be pretty high, right? And
Yeah.
so, like, you know, that's a tough tension. You want the student to succeed, you want them to learn to, and by doing is a good way to learn and making mistakes, but also, you need that paper too, and
Yeah. Yep.
you want them to actually get the paper and move on to the next thing and everything. And
Mm,
it definitely takes some time to strike that balance well, I think. And seems like you've managed to do that, even really in this paper. But obviously,
mm,
learning from things that you could have done even a little bit better is
mm,
really how you become a great scientist, I think, as far as I
mm.
can tell. Yeah, and I was wondering if you could also tell us a little bit about what these results tell us about the human brain, or behavior in humans.
Yeah. And that's something we've been thinking. I mean, we continue to think about, but we're definitely thinking about in terms of this paper, especially since a lot of the work that we had been doing outside of just the receptors and the pathways was thinking about the circuit as well and how that actually is implicated in substance use disorder and also in mood disorder. So, I mean, a lot of our work, a lot of times when we're writing grants, we're saying we're trying to understand the neurobiology of substance use disorder or anxiety or depression. And then we're also trying to identify therapeutic targets that could help with symptoms that people might be experiencing. There always feels like there's a tension there because you can drill really deep and find out what's happening in a specific locus or a specific cell type. But is that actually going to translate if you're looking at, let's say, a cholinergic receptor as a target for a therapy? So part of that was really trying to understand what's happening in the whole circuit. If we're going to be using cholinergic agents as therapeutic agents, if there's a lot of evidence showing what nicotinic receptors do in the striatum, we need to know what's happening elsewhere in the VTA and in the whole brain, how that actually impacts the whole system. So sometimes we would do that with systemic administration of specific agents and then go and do locus specific manipulations to see how the locus activity is implicating what's happening when you give something orally or with an IP injection or whatnot. But our motivation at that point was saying, well, we need to at least understand what's happening at the VTA where the dopamine neurons live and not just at the accumbens so we can have a better sense of what's happening in the circuit. So I think for us, that was a really important question. And in terms of full disclosure, we haven't done as much on nicotinic receptors recently, but we're using that same approach when we think about another target. We're looking at L-type calcium channels. And again, there are FDA approved medications, antihypertensives that are already on the market. There's an increased understanding of how those are also impacting the brain. There's a lot of evidence showing L types that are important for neuropsychiatric illnesses. And so, in the same way, we're trying to say, okay, we are looking at specific locuses and loci, but if we give this agent systemically, how does that locus effect actually impact? Is that a critical piece of the puzzle? And so, I mean, I think you can hear as I'm saying, it's always a tension that goes back and forth, not just in the publications, also when you're writing the grants, when you're trying to have collaborations that might have clinical implications. So, in some ways, even though our research question has shifted, some of the principles are still the same. And those are some of the things that we often think about, not only in terms of how it impacts the field and our understanding of brain circuits, but how, if translation is our goal, how it's also impacting how we'd be able to actually move things into a clinical model.
Right. Yeah, that strikes that another balance. I think really well. And all of us really are in some way or another interested in trying to translate our basic neuroscience findings into things that can actually help people somehow.
Mm,
And I really like this approach you're talking about, where
mm,
you have a sort of a tool of some kind of drug that you could give
mm,
systemically to a human, but there's many questions you'll never be able to ask in humans about how it actually may work and what that it can actually tell us about brains in general and maybe human brains perhaps even in particular, and how these circuits are actually underlying these therapeutic effects you're seeing. So I love this idea of, like, you start with something that could be turned into a human drug, for example, and then look at it in a very mechanistic way, to try to learn more about, like, why it's actually doing that. And to me, that's exciting, both because you may end up with a new compound that could actually be
mhm.
really useful for depression or addiction. Um, but then we also may learn some fundamental new things about the brain, which is,
Yeah.
I think, really exciting as well, and is certainly part of my motivation as well for
Mm,
doing this kind of research, is the quest for basic knowledge, as well as
yeah.
applying that knowledge to an actual treatment or something like that.
Mhm.
Um, so very cool. That's I think really, really exciting stuff. And I was wondering if you could also tell us a little bit more about what you think are some questions that you didn't end up answering in this particular paper, or maybe even in your subsequent work. What are some big holes in the field? Like, what are the things that we really need to know when it comes to this kind of research topic that we don't right now?
Yeah, so I would say some of the things that we didn't get to address as much. So, I mean, it was a psychopharmacology paper. We did different doses. but you can only do so much. And then we also did this in the nest preparation. So one of the questions that was really hanging in our minds, which we just ended up shifting and pivoting elsewhere, was thinking about these alpha 6 nicotinic containing receptors that we now saw were regulating basic dopamine release that was consistent with what people had found in terms of the physiology, the burst firing dopamine neurons, but to see what effect that has behaviorally in behaviors where these types of dopamine responses are involved and important. So one of the things that we were thinking about in particular was how cues can facilitate relapse. And so we started to look at some of that. We end up shifting a little bit and looking at more muscarinic receptor mechanisms, which are also important. So another subtype of acetylcholine receptors, not subtype, but another class of acetylcholine receptors. And so if we had all the time in the world and we had lots of questions we could ask simultaneously, which goes back to the first point I made, we don't. But the alpha 6 piece was something that we were particularly interested in. And also looking at that potentially across different classes of substances. So not only thinking about stimulants, but thinking about depressants, and then with everything with the opioid crisis that we're going through, and really think about, are these mechanisms consistent across classes when you present cues that are maybe associated with heroin or amphetamine or nicotine or cocaine or alcohol? And if so, can we develop an agent that can be used across the board? I think that's one of the big pieces that we're still thinking about. And just to complicate things even more, this isn't in the paper per se, but we also have to think about the types of behavioral models that we use. So, I mean, this was a very much physiological type of assessment, but then we also have to think, is the model that we're using behaviorally actually relevant to someone who's using a substance or misusing a substance? And if it's not, do we make it more so like that? Maybe thinking about things like choice behavior, and then go and see whether, again, these alpha 6 receptors are actually playing a bit and critical role. So it's one of those where we did find something very mechanistic, but there's so many different questions we could ask big picture. And then we have to be even more careful about how we design those experiments.
Absolutely, yeah. So do you think then, just speculating, do you think that we're going to ever come up with a, let's say, a compound or some other kind of intervention that will actually just kind of cure or at least help with addiction across the board, across all these classes of drugs, for example, or across people that, are addicted maybe for different reasons, more genetic components versus environmental things that happened in their childhood, adverse events and things like that? Or do you think that we're going to have to sort of tailor these approaches a little bit more to the individuals that actually come into the clinic? Again,
Mm.
speculation, since I don't think we know the answer to this yet, but
Yeah,
what do you think?
that's a really great question. And so, interestingly, my answer to this isn't necessarily informed by my science, but more so by my science engagements in community. So my initial reaction, just anecdotally, is that no, it's not going to be one specific intervention that's going to work across the board, even if that's a pharmacological intervention. And I say that just because of what I've seen and talked about when thinking about mental health in general in communities. And one of the phrases I always use is there's no one size fits all when it comes to mental health, because I've seen too many times where people have that approach either intentionally or unintentionally. They try one approach, that approach doesn't work, and then they just keep trying that one approach harder, or they just stop. Whereas those who are able to say, okay, maybe I tried a medication and that didn't work, but now I tried therapy and that got me over the hump. Or vice versa, therapy wasn't working. I tried medication. Medication made it easier for me to actually access a therapy. It's working better. Or I tried a spiritual approach and that really helped. I had like some prayer practices that helped move me through. Or I tried that and it didn't work and I had to integrate. So, or talking to a counselor, whatever the case may be, just being in community with other people, having somebody who just checked in. So in my mind, if I'm looking at globally and seeing that that doesn't work for many different aspects of our mental health, I also wouldn't expect that to work more so just focused even on substance use disorder or anxiety or depression. And in a way, that does still tie back to neurobiology, because if I just think about the brain, people who experience a trauma or someone who's used a substance or someone who has anxiety, we might call all those things the same, but we know that those are all different things that are happening. Two people might both have depression and have very different brain biology that's leading to that depression. And so if they have different brain biologies leading to depression or substance use disorder, they probably will have different brain biology that's going to actually change and help them alleviate those symptoms as well. So all that always says, well, it's more complicated than we want it to be, but I think it's also the reality as well.
Yeah, I couldn't agree with you more. I think part of the issue here is that like us neuroscientists don't think about these complexities as much as we should. And also, just as you pointed out, we probably don't interact with people who actually have these disorders, especially, diverse populations of people that are under different circumstances and things. So that insight that you just mentioned there, I think, is one that we all need to internalize a little bit
Mm,
more as neuroscientists. There
yep.
may not be a magic bullet for depression or for addiction. It may be that we really have to look at people as a whole and try different things depending on what's, wrong with them or what's
Hmm.
troubling them at that moment. That's part of this I think may also come from the way we handle psychiatric disorders in our society or in our country, based on, for example, the Diagnostic Statistical Manual of the APA. If you want to define depression, and you want to look in that book and see what that means, it's, a couple, like I think it's like three or four of the following nine symptoms. And if you have up to four or more of them, then you are considered clinically major depression. But those four might be totally different four than another person who
Hmm.
has the same diagnosis. And
Yeah.
how are we expecting to really do a clinical trial, for example, with two populations and
Yeah.
hoping that our intervention is going to, affect them both? And maybe it works great in half of them or a third of them, but not at all in the others. And now that's considered a failed trial. That's
Mm,
maybe not the only way to do
yeah.
this.
Yeah.
Yeah, and that also brings me then into the another thing I'd like to ask you about a little bit more is um, this process of interacting with wider audiences when it
Mm,
comes to communicating our science. This is something that you are, I think, really at the top of the game in, and I'd love to hear a little bit more about, like, what are the kind of aspects of science communication that are exciting to you right now. Obviously we have your popular podcast, and I think you have some other things going on. If you could tell us a little bit about what you're up to and what you feel like is most exciting in that domain at this time.
yeah. Definitely appreciate that question. It's funny because I think about this almost in the same way that I think about lab development as well. So I was talking about early on, we had this one question that we were trying to address in the paper. And that was for very practical reasons. We had to establish and build and understand what we were doing. But then, of course, the lab has grown over time. We're asking many different questions. We're now doing comorbidity between substance use and mood disorders. We're looking at flavors that impact nicotine use. And so we've been able to ask more sophisticated questions over time as we've been able to kind of build expertise in certain areas. And in some ways, I feel like I've also been fortunate to be able to do that in the broader sense of public engagement. So some of those things start out with pretty small engagements. I mean, even things like, talking about neuroscience to fourth grade classrooms. Not that that's minimized in any sense, but that was a very good starting place to say, okay, can I actually communicate this information in a way that a fourth grader will understand? And having a challenge and having to learn how to do that more effectively, and then to be able to build that to say, okay, well, can I step into another environment? Can I step onto a college campus, even though I'm at a college campus, but not in the way of, am I just speaking to a group of undergraduates and parents during Parents Weekend and thinking about these aspects of substance use disorder and how that interacts with people's everyday experience to really have those types of conversations and to be challenged with that as well. And so for me, those opportunities have continued to come as I've continued to allow myself to be stretched into an environment that I wouldn't necessarily speak at. One of those was at a public library talking about the neurobiology of addiction. And then having people who are part of a recovery house come to that event and to ask questions. And so that was very much a dialogue back and forth where they were able to talk about their own experience. And I was able to talk about what we know about the brain, but we were able to learn from each other. So it wasn't me as the quote unquote expert telling them, well, this is exactly how it should be, what should happen, but then also them being willing to share their experience, but learn at the same time. So I'd say as those things have continued, I've one thing I've always tried to do is to learn from each engagement and each group that I'm with. And I think that has allowed me to actually step into new opportunities and new places. So I've been able to speak to boards of education. I've been able to speak to businesses. I've been able to speak to a group of lawyers. So all and each time I do that, this is a growth piece. It's always a stretch because it's like, okay, now I took it to another level with another group that I have to now figure out how to communicate to this group also. I mean, I've also on the podcast just had a lot of different conversations. Our tagline is neuroscience, mental health, faith, culture, and social justice. And so I've been invited to speak at different venues on health disparities in mental health. And so also realizing this is again maybe our training. I don't have to have a PhD in that to be able to speak on it from my experience or to be able to read on it and to be able to deliver that. Not to pretend that I'm an expert, but I think sometimes we get stuck in this. If I didn't study this for 4 or 5 years and write a dissertation on it, then I can't say anything about it without realizing that we can still learn as we're going along the way. And so lots of opportunities have opened up for that. And the most recent is a book project that I'm actively engaged in. Again, trying to communicate neuroscience to a very broad audience and think about all these components. So in the same way that Lab kind of develops, I feel like I'm also developing in terms of taking opportunities of places where I can step into the conversation and still lead with the neuroscience, but then also learn from all these different components and integrate that together and collaborate with other people. So it's not something where I'm doing it on my own.
Interesting. Yeah, that's
So that was a lot.
no, no, that's fascinating. I was wondering if you could say if anything comes to mind. I'm really intrigued by this idea that in these science communication formats, it's not just the expert coming in and saying, "Here's how the brain works. Learn from me." You're actually learning from the audiences, and the different audiences are teaching you different things. I'm wondering if anything comes to mind as to something that you've specifically learned from one of these engagements or one of these, writing or doing the podcast or any of these speaking engagements that really kind of changed the way you think about science or the brain.
Yeah, a couple things come to mind. So even as I was talking to that public library and people were talking about their experience with medication assisted treatment. So for those who don't know, if someone has had a challenge or a struggle with opioid use disorder, they'll often get different medications to actually navigate through that. And I'll just say in my basic science settings, we talked about that in a very, what felt like a very concrete way. Well, you give this agent or methadone or something else and it does X, Y, and Z. When I was in that environment, people were saying I took X, Y, and Z and it made me feel horrible and I wanted to get off of it. So it just changed my perspective because all the conversations I had before didn't have any component of people's experience. It was very much this is what's doing to the brain, this is how it's going to help people. Granted, I wasn't in a clinical setting, but it was very helpful to have that feedback from people and to think about, well, what are people actually experiencing? I think at the same time, this wasn't your question per se, but they also learned things because some of them walked into that room saying, well, I don't see this as an illness because I did this to myself, which is true. And I think I've mentioned that to you before. It's true on one extent because you have to use a substance to develop addiction. But by the end, they also said, okay, now I'm seeing that this actually has long term effects on my brain. I have a better understanding of that. And I also understand I can get to a new normal. So it's not a hopeless situation. The other thing I would say that I've learned is just how to talk about certain things. So as I've interviewed different guests on the podcast, one person that comes to mind is Sean Astin, who's Patty Duke's son, and him just talking about his mom and what she went through as a person living with bipolar. And at that time, when that it was very heavily stigmatized, let alone an actress who was navigating through that. But the way that people always talked about her as someone who was struggling, and just that phrase as if you live with a mental illness that you're always struggling, that you're not thriving in life. And so just small little things about what words do we use? Is someone struggling or are they navigating through something? Can they still thrive? Can they still have wellness even if they live with a mental illness? So some of those conversations have actually impacted how we're writing our papers when we're talking about substance use disorder or depression or anxiety and what language we use in the introduction when we're talking about the prevalence of it or clinical populations. And so it's small little things like that, but it not only impacts how we write the papers, but how we talk about that as a lab group and how we talk about that in our talks, scientific talks, how we talk about that in our interactions with everyone that we interact with on a day-to-day basis. So there's a lot of practical ways that I think all of us can kind of learn from those experiences and have it impact what we do on a day-to-day basis and our perspective. Again, if we're going back and just talking about, well, this does X, Y, and Z in the brain, we forget that we are all people and we experience things like those also matter.
Yeah, absolutely. Yeah, it's something that I think a lot of times trainees have issues with is they come into a lab, they are learning a bunch of stuff for the first time, and they don't really feel like they know anything. The more you know, the less you feel like you, or the more you learn, the less you feel like you know, actually, a lot of times. And I think having this basically the idea that in fact they are not just there to learn things, but they're there to contribute their own perspective, and that may
Mm,
involve experience with mental illness, either personally or in their families. They may involve different life experiences. I think it's really crucial for these dialogues to occur. I love, this idea of doing it, talks and interactions with various communities. And I also think it's important for us to bring in people with different backgrounds to our own
yeah,
labs, to be in those
yeah.
conversations on a weekly basis or more,
Mm,
even to discuss the science, to learn from, individuals who know
Yeah.
things that I don't know and I've never heard about before, and that can absolutely inform our science all the time. So I think the trainees really need to keep in mind that, especially when they're writing that
Yeah.
first paper, which can be kind of daunting, that this is a kind of all this whole endeavor of science
Hmm.
that we're doing here is a kind of a work in progress, and we need all the input we can. And I think diverse perspectives is absolutely essential to that
Yeah.
from the way I
Yeah.
look at it.
That's a great point. And just to follow up on that, I mean, I've seen so many times when trainees have come into the lab and changed the question the lab is asking, changed the culture, or brought things to people's mind that people weren't thinking about or things to be attentive to. So, I mean, just the same point you're making, the trainees as trainees, you also can impact the entire lab dynamic. And that, I mean, that can go both ways. That can be good and that can be bad. So that's also something to think about. But so many times, I mean, just I feel like so many things that students are fighting for these days, they can actually bring to our attention and bring to the lab's attention to help us be more attentive, like you said, to so many other important things.
Yeah, and even when it comes strictly to the, process of science and developing treatments and things like that, we have not really done that great of a job on this in this
Mm,
and in the domain of psychiatry. And I think we have spent probably too much time, circling around the few things we do know, like, we have antidepressants which act on catecholamines, and so basically everything we've done in the last 60 years came from that sort of basically accidental finding of a discovery of
hmm.
drugs that impact these things, help people with depression. And so we came up with this whole theory of depression and serotonin and everything. And we haven't made a lot of leaps beyond that
Hmm.
yet. And I think
Hmm.
part of the problem is us sort of looking under the streetlight for our keys, that classic like analogy, we're just sort of, we know dopamine's involved. So let's study dopamine. And that is important to do. We
Mm,
both do it.
yep.
But it's maybe not all there is to it. Maybe we do
Yeah.
need to think about things in a broader perspective. And that comes from other perspectives. It really does.
Yeah.
And I'm wondering if you can tell me a little bit more about like if I'm a junior scientist, if there's a junior scientist listening who would like to get more involved in this kind of science communication outside their own labs, but maybe in a broader way or maybe as a career path, is there any advice that you could give to a person like that?
Yeah. So this is funny because it goes back again to that same idea from starting the lab. I always tell people just to start with small steps. Because sometimes we feel like, okay, we have to have this gigantic new idea. Or I'm going to start this whole new nonprofit or this whole whatever that might be. Whereas it can be a stepwise process. So I mentioned like I went to a fourth grade classroom and then I was speaking at a library. So I mean, a lot of different schools will have outreach events that they'll do in the community. So even just finding out like, is there brain awareness week that happens in your community? And can you actually go and speak to those kids as a starting point? Or, I've spoken to high school students. I mean, there's so many different opportunities that are really helpful for learning how to communicate in that way, but then also giving you a feel of like, well, do I actually like this interaction when I'm doing it? And so sometimes those things can actually build because there's so many different places that we can plug in. I mean, I'm even thinking in terms of local government, like if there are different initiatives that are happening around anything. I mean, I have some students who worked with their local governor's office because there were needs and they were able to get involved in science communication in that way. So I would say, yeah, just be really practical about it and not try to you know shoot for the moon on that first initiative, but that also gives you time to kind of grow and develop and hone your skills too. I mean, I'm glad that my first science communication was not in front of an entire board of education and superintendents for the state of Connecticut, which I was able to do later. I'm glad that was a little bit later when I had some time to refine that. One, I don't think I would have known what to say in that environment, but just having that learning along the way. Then also realizing, I mean, not to say that those individuals are more important than others, but I also had to have a certain level of preparation to actually step into that room and say something that was going to meet them where they were at. So for me, it just feels like a growth thing. And I would tell people just start practically, start locally, see what things are already happening and what can you tap into.
That's awesome. Yeah, like many things in life, including science itself, practice makes perfect. Almost
Mhm.
every single aspect, science communication, certainly, as you just pointed out, and doing the techniques and writing papers and grants and things, all these things just take time, perseverance, and a lot of motivated interest. So, once you find something you're passionate about, a lot of that just
Yeah.
comes right along with it, and you just need to
Yeah.
get better at that thing, and that's how you make a career, seems to
Yeah.
me.
I mean, the other thing I would add there too is that people shouldn't get discouraged when they make mistakes because they will. I made mistakes, and that actually is what helped me become a better science communicator. I was like, oh, I said it this way, and people really didn't know what I was talking about. So then that allowed me to kind of hone the craft. But I also had to have patience with myself because, especially in science, I mean, we know that that error is there, and there's going to be trial and error. But sometimes, at least for me, I didn't always extend that to other arenas as much as I should have. And so realizing that developmental process and making those mistakes and having those trip ups is still helpful for my development. It helps me communicate better the next time.
Absolutely. Yeah. Failures are only failures if you perceive them that way. They can be
Hmm.
opportunities for growth. It really is like that. And I'd almost think of it as I sometimes tell students everything we're doing almost is if we go back and look at it in 100 years, like every paper I've ever written, probably the ones you have
Mm.
written, they're going to seem kind of silly in some ways
Hmm.
because we don't really know what we're doing here. We're just trying different stuff
Yeah.
and making progress slowly and steadily. But that is involving one way to look at it is that's failure, and we're just kind of wasting our time. But I certainly don't look at it that way. I look at it
Mm.
as that's how we get to where we're going to be in 100 years,
Hmm.
hopefully in a good way.
Yeah. Yeah.
This is the process. Science ultimately is putting an idea out there, and other people will say, "Oh, you're onto something, but you're kind of wrong about this part." And so let me do some experiments and prove where you
Yeah.
are wrong. And that's doesn't mean that the first
Yeah.
paper was a failure or a
Hmm.
mistake. It means that it was, would have been wouldn't the progress couldn't have happened without that
Yeah.
mistake or an inaccurate thing that's in the world. And I think a lot of times trainees, especially when you come into grad school, you're coming from science classes where you're reading things in books that are facts and
Mm.
you're memorizing them and it works like this and not like that. And then once you get into the trenches, so to speak, of the actual process, you realize,
Hmm.
oh, there's a lot of stuff that's we don't
Yeah.
know and things that we thought we knew, but kind of actually it's not really like that. And that can be discouraging a lot of times. But I
Mm.
think, I always try to really proactively tell my students that this is a good thing. This is how you make progress. In fact, it's not failure is not a bad thing.
Yeah.
Um, and
100%
then
agree.
and then I was wondering if you could also tell me from your perspective, what are some of the challenges that we are facing these days when it comes to science communication?
Okay. Where do I start? So I mean, I think part of that is just also just the information overload that we have. So I guess I'll take it from the receiving end first to say that for those who are receiving scientific information, it can be very difficult to know what is opinion versus what is fact versus what is, I guess, the best way to say hypothesized. And that's because everything is presented as fact, even if there's no fact behind it, if nothing has been done. So I think for us as scientists, that puts onus on us to be able to try and communicate effectively. And that's not to say that we have to have, a national media presence. That can still be just when you go and talk to kids in the elementary school and just getting that information in early on. Or when you talk to community groups or just people that you bump into and then you tell them what you do for a living. So I think we also have to be more willing to do that. I know at least for me, I had a lot of hesitancy about doing that early on, but I think there is just a lot of noise out there, which makes it difficult. And then the frustration comes. I mean, I'm just thinking about everything with COVID-19 when the science is put forth in a factually correct way, but it's not interpreted that way. And then that becomes very challenging. And then sometimes it can be too much to try and tackle everything at once. I mean, in some ways, if someone's mind is so made up, for instance, that COVID-19 isn't real and it was made, you're not really going to convince them just because you keep trying harder. So part of it is also knowing one, trying to communicate effectively, but knowing when it's not worthwhile in that instance because someone's mindset has to change. You can just keep trying, and you're not going to make any impact there necessarily. The other side of that, which I alluded to earlier, though, is also being willing to say things without having a study with 10,000 subjects to back you up. I think sometimes we hesitate as scientists more than we should, and I've had that come up at times as well, where we forget that not everybody has studied a specific scientific discipline as much as we have. And so even if we don't know much about it, but we know a little bit, that little bit can still go a long way, even if we don't study that thing per se. So I mean, I've had people ask me questions about, children on the autism spectrum disorder or what happens with trauma. And granted, these aren't things that I've studied, but I've hosted enough people on the podcast and interacted with enough people to say, oh, well, this person here was studying this aspect about it, and what they found was this. That's still valid. I don't have to own it and be like, what I studied was this, and this is what we developed. I can still communicate other people's science, and that's still science communication. And sometimes I think we forget that we don't have to be the expert on all the knowledge. It's fine to take advantage of the work other people have done and communicate that to others, because in some ways we're translating that for the general public as well. So that was beyond your question, but those were some of the things that kind of came to mind.
Well, that's great. Yeah, and I think it's for part of the thing that I think is so great about the stuff you've been doing in this domain is you really are talented at making these connections with people and sort of
Mm,
parsing this fine line of like how much detail is enough to get the point across, but how much is too much, that kind of thing. And I think that not all scientists really are naturally interested in or
mhm.
naturally good at this kind of thing, and that's okay too. I mean, there's
Yeah,
room for
definitely.
everyone here, and I do think that some individuals like yourself can play a special role by helping actually get this stuff out there in a way that
Mm,
people can understand. It's not just like eggheads talking about fancy words or whatever, which
mhm, mhm.
is what we do a lot of amongst ourselves, to be honest. And we started this conversation that way, I think,
Yep.
frankly.
Mhm,
And that's fine too, because we are talking about it at that level. But when it comes to actually getting it into the general population, it may be that some people just want to take on this as their main focus, and I
mhm.
think it takes all kinds to make a difference in the world here.
Yeah, that's a really good point. And I think, to that point too, because not everybody feels comfortable doing that, but then hopefully there are some of us, and I know Aaron Calipari made this point as well, where someone can say, like, I don't feel comfortable about this, but I know about this resource, so let me point you in this direction, or why don't you listen to this conversation that this person had, or there was this book or thing that might be helpful. And I think that is also really important and really valid. And I think you were, hinting at that as well, that it can just open up some of those doors. So the more people are talking about it in general, the more opportunities everybody has to kind of tap into something, even if it's not their comfort level to actually speak on it per se.
Yeah. Yeah, it's another thing that occurs to me is sometimes I think people just think of scientists as something different or, over there. It's just
Mm,
not like my kind of people or something like that.
mhm,
And I
mhm,
think just sometimes I've had experiences where I sit down at a bar, for example, and I start
mhm,
talking to someone who's there and they really don't know any scientists and they sort of have a
mhm,
bunch of ideas about what science is like. And, they
mhm,
may have heard, for example, that the climate scientists are doing all this, making all this money on stuff and like, they have an agenda and stuff like that. And I'm not saying that there's nothing like that in science. We are all humans and there's a range
mhm.
of different people's motivations and whatnot. But I also think that, even just the talking about the process and being a relatively
Yeah.
normal human who happens to
Yeah.
be a scientist can have some value right there too. Now they
Yeah.
now they just sort
Yep.
of don't think of scientists as like the only example you have is from movies where they're doing terrible things or whatever. We are real people too,
Hmm.
and that I think has a little bit of value potentially as well,
Yeah. Definitely.
especially when the people are good communicators like yourself, of course. But um, yeah. So, well, anyways, I think we'll draw to a close here. And I just wanted to tell you again that I really appreciate your time, and this has been a fascinating conversation. I hope people will tune in and pay and check out your book when it comes out. Which are we expecting that this year or
May 25, so it's got a little bit of time, but there'll definitely
May
be some
25?
information leading up to that. It's a enjoyable, interesting, and intense process.
I
It's kind of
bet.
the best
Yeah,
way
I
to put
bet.
it.
Wow. Well, I'm certainly looking forward to that myself. And in the meantime, I guess I'll have to make do with your podcast and scientific papers, which is perfectly good with me as well. So anyways, thank you again, Dr. Addy. This has been a really wonderful conversation. And again, appreciate your time. And thanks
Of
again.
course. Thanks so much for the invitation.